Welcome students. Today we will take chapter 2 Polynomials Factor Theorem. Now let us define factor theorem. If Px is a polynomial of degree n greater than 1 and a is any real number, then x minus a is a factor of p of x. Now a should be a real number and x minus a is a factor of p of x if p of a is equal to 0. Now suppose if we take p of a in place of p of x, it means we are replacing this x with a. If here we are replacing x with a, here also we will replace x with a. Then what will we get? We will get a minus a that is equal to 0. That means p of a is equal to 0. If such is the condition, then x minus a is the factor of p of x. And the in reverse of it is if p of a is equal to 0. If x minus a is the factor of p of x, it means if we take p of a 0, then automatically x minus a will be the factor of p of x. These both are meaning the same thing in short. And we did not worry about the definition too much. We can understand the definition by going through the sums. Within the sums itself lies the definition. So when I will explain the sums, I will tell you what the definition was about too, about the meaning of the definition. Now see, this is the question. And they are asking you that which of the following polynomials has x plus 1 as a factor. Now, I every now and then compare this particular sum with the general statement. The general statement is x minus a, and here in the particular sum, this is x plus 1. Now, what will be the value of x? If we take p of a is equal to 0, it means we are going to take x plus 1 is equal to 0. X plus 1 is equal to 0 means x is equal to minus 1. Just like this one. If x minus a is equal to 0, then x is equal to a. Similarly, if x plus 1 is equal to 0, x is equal to minus 1. But why should we take that? What is the reason of doing all that? We are going to see whether it is a factor or not. If it is a factor, then our remainder, it means p of a will be 0. In this particular sum, we are seeing that 0 over here. This 0 and this 0 are same. If you get 0 as your answer, then that particular value, that particular x plus 1 or in general x minus a, both are called factors of the polynomial, this polynomial. And in general, we call the polynomial px. Now, I think we are clear with the factor theorem. What should be our answer if x plus 1 is the factor? Our answer should be 0. If our answer is 0, then x plus 1 is the factor of which polynomial? The polynomial that is given in the question. Here it is. And in general, we call this polynomial as, just recall I told you just now. In general, this polynomial is denoted by p of x. And what is this denoted by in general? Recall what is this denoted by in general. In general statement, what is this much part replaced by? General statement is over here itself. Just find out. Yes, it is x minus a. And what are we doing in general statement? We are taking x minus a is equal to 0. In this particular sum, we will take x plus 1 is equal to 0. If we take x plus 1 is equal to 0, what will we get as the value of x? We will get x is equal to minus 1. That is called the 0 of x plus 1 is minus 1. Then what will be our next step? Wherever we will find x, we will replace it with minus 1. Just as I told you, you replace this x with a. This is our a. Now wherever you find x, you replace it with minus 1. Here you are seeing the replacement of x with minus 1, and here are its answers. Be careful that if the power is odd, the negative sign will remain negative, and if the power is even, the negative sign becomes positive. That rule is applied over here. Minus 1 plus 1 is 0. Again minus 1 plus 1 is 0. Hence we got 0. Whenever we get the 0, it means that particular polynomial has x plus 1 as a factor. It means this part is the factor of the polynomial. Now I will ask you one interesting question. You just think it over. I will reply it after the presentation is over. What about the remainder in this type of sums? Now here we are dividing this polynomial with x plus 1. Think of the long division method. In long division method, this will be the divisor. This will be the dividend. And think it over, what will be the quotient? What will be the quotient and what will be the remainder? In particularly, think it over, what will be the remainder? I'm asking what will be the remainder in this particular question. Think it over and reply to me later. Here I am with the second question of the same type. The same x plus 1 is there, and we have to find out whether it is the factor of this polynomial. For that, you take x plus 1 is equal to 0, therefore x is equal to minus 1. And we call it in mathematically that the 0 of x plus 1 is minus 1. Nothing very difficult. You have to just write that the 0 of x plus 1 is minus 1. Not a big deal. This is not a big deal. Just understand the statement. We have done nothing. What we have done, whatever is over here, you put it equal to 0, you will get the value of x equal to minus 1. And then the next step is replace x with minus 1 in the polynomial, whichever is given in your question. See, the steps are very simple. Your calculations should be perfect. Here just you have to replace x with minus 1, as you can see over here. All the value of x are replaced with minus 1. This is constant numbers. And again here you can see one x, but I have replaced it with minus 1. Now we will calculate. So p of minus 1 is equal to minus 1 cubed will be minus 1. Minus 1 squared is 1. 1 into minus 1 is minus 1. Here be careful. See, minus 1 is here also and minus is here also. So minus into minus is plus. And here you are having in the bracket 2 plus root 2, but remove the bracket. So you get 2 plus root 2, and the final root 2 is over here. Hence, what is the answer after doing calculations? Minus 1 is minus 2. Minus 2 plus 2 is 0. And here root 2 plus root 2 means 2 times root 2. 2 times. Times means multiply. So 2 times root 2. Or you can even say, see, here 1 is hidden. 1 root 2 plus 1 root 2 is equal to 2 root 2. Now, in the previous question, you were getting answer 0. But in this question, you are not getting answer 0, but a number. 2 root 2, a real number. That is why x plus 1 is not the factor of the polynomial given in the question. If you get any real number, then it is not a factor. You have to write this one is not the factor. Again, recall what is the general name of this particular linear polynomial. This is a linear polynomial. What is its general name in the factor theorem? Recall. Find the value of k if x minus 1 is the factor of p of x in each of the following cases. Now here, hard and fast, it is given that x minus 1 is the factor. So you are not going to decide. It is already decided that x minus 1 is the factor. In the previous two sums, you had to find out whether it is a factor or not. In the first sum, it was a factor. In the second sum, it was not a factor. So it was not pre-decided, but here it is pre-decided that x minus 1 is a factor. If it is a factor, then your answer will be 0. That is also pre-decided. Now, what is the 0? What is the value of 0? If x minus 1 is equal to 0, then what is the value of x? Then x is equal to 1. And it is pre-decided that p of 1 is 0. First, what you have to do, you have to take x minus 1 is equal to 0, then you get the value of x. X will be equal to 1. Then you must replace x with 1, p of 1. But now you need not find out whether it is 0 or not 0. It is 0. It is compulsory 0 because it is given that x minus 1 is the factor. In the previous two sums, it was not given. There it was given that find whether it is a factor or not. Here it is given it is a factor. So you understand the difference between the questions. Once you understand the difference, you will understand why we are writing here 0. We are writing p of 1 is equal to 0 in the first step itself. There we were getting 0 in the last step. Here we are writing p of 1 is equal to 0 in the first step itself. So by factor theorem, now we will replace x with 1. This we used to do in the previous sums also. We used to replace x with the value of x. The same method is over here. And the same thing is there. Wherever you are finding x, you are replacing it with 1. But here you don't know the value of k, so you put it as it is plus k. And the interesting part is that we are going to find this k. That is what is asked in the question. Find the value of k. Right? So here we have done the second step. That is we replaced x with 1. Now in the third step, we are writing in RHS 0. Why? Because I told you that p of 1 is equal to 0 is already given in the question. That is why we are writing in RHS 0. And one more interesting part is that if we do not write this 0 in RHS, how are we going to find the value of k? Think it over. Think it over. Think yourself. स्वयं विचार कीजिए. Okay. So x1 squared plus 1 plus k is equal to 0. Now this is already pre-decided. Now it is very simple. You have just to find the value of k. 2 plus k is equal to 0. Therefore k is equal to minus 2. That is the what is required in the question. Here there is another question. The same thing is there, that you have to find the value of k, and our factor is x minus 1. If x minus 1 is the factor, then what will be the value of x? It will be 1. How did we get it? X minus 1 is equal to 0. Therefore, x is equal to 1. Now we will replace this x with 1. We get p of 1 is equal to 0. This is already pre-decided, and this will be the first step. Now you will put p of 1 is equal to, you will replace wherever you are finding x in the question, you will replace it with 1, as you can see over here. After replacing it with 1, you have to write that is equal to 0, because it is pre-decided. P of 1 is equal to 0. So here we are writing equal to 0. And then we are going to add these two numbers, 2 plus root 2. Let them be in bracket, because they are 2 are the numbers and k should be separated from it. So let k be in LHS and bring these two numbers in RHS. Both are going to be minus. They will get, the sign will get converted into minus, because both are positive and both will become negative. So it's better we write them in the bracket and then put the negative sign outside the bracket. That is called, you have taken the negative sign common. And we got the value of k, which was the requirement of the question. Here is an assignment for you. There are 4 questions. Practice it in your notebook. All the best. Thank you.